Okay, so welcome again to the second lecture of this course, Fundamentals of Solar Photovoltaics and Technologies. I am Ashish Garg, Professor at the Department of Sustainable Energy Engineering at IIT Kanpur. So let us briefly recap what we did in the last class. In the last class, we learnt about the importance of energy. Energy is something that is ubiquitous, and we need energy for almost everything that we do, whether it is just living, running, walking, hunting, searching for food, agriculture, climbing stairs, going for a walk, even sleeping, we need energy. We need energy for every operation that we carry out. Typically, in the past, energy was derived from fossil fuels. When we were hunter-gatherers, we did not have too many gadgets. All we required energy was to be well, eat well, sleep, and do some other activities. But as we grew technologically from a hunter-gatherer to a civilized man, for example, we went into Bronze Age, then Iron Age, and today we are in, then we were in Industrial Age, and now we are in Electronics Age, AI Age. Transition from hunter-gatherer to a civilized man until today has given rise to a lot of technologies. For example, development of metals, development of power, electricity, mechanization, automation, internet, a lot of goods that we wear or use, computers, mobile phones, tablets. All of these goods on which our modern life is built upon, in addition to food, is based on use of energy, because producing all these goods requires substantial amount of energy, and today all of this energy comes just not from biomass, it comes from coal, which is the primary driver of our energy demand, our energy supply, from oil and gas, which we use not only to produce electricity but also to drive our vehicles, our different other operations, cooking, heating, etc. And this energy need has increased steadily since the Industrial Revolution, which has caused a substantial increase in the production, extraction of coal, oil and gas from the resources underneath the earth or outside, and then converting them into useful products that we have in their forms today. So this increased gas and coal production has increased our energy supply, but this is not without the consequences. So the question is, what are the consequences of having such a huge energy demand and having to rely on sources which are fossil fuel sources such as coal, oil and gas. So this is what we are going to discuss in this lecture, the very basis of why we want to move towards cleaner sources of energy. So consequences of fossil fuel consumption are manifold. First of all is unabated use of natural resources, mainly for energy, for variety of minerals for making different gadgets that we use. And again, for excavation of those minerals we need energy. So basically it results in unabated use of natural resources, which results in mining, destruction of natural ecosystems, a lot of water is wasted, a lot of pollution is created. It leads to pollution of ecosystem, meaning it leads to pollution of soil, it leads to pollution of water, it leads to pollution of our water bodies, it leads to pollution of air. And all these three things are important for our living. We need food from soil, we need oxygen from air, and we need water for our survival and many other things. And this happens because of, especially in the context of air, this unabated use of natural resources leading to burning of many of these natural resources such as biomass, coal, oil and gas. It results in emissions of gases such as carbon dioxide and many other greenhouse gases, whose emissions have a strong effect on our planet, a strong negative effect on our planet in the context of the well-being of every species on the planet. So what happens when we burn these fossil fuels? We extract a lot of fossil fuel and we generate energy by burning them. So what happens when we burn them? when you burn fossil fuels, we release a significant amount of carbon dioxide, which is a greenhouse gas, and as we will see later on what is a greenhouse gas effect. Not only carbon dioxide, but also other gases like nitrous oxide into the atmosphere. These gases intensify what we call as greenhouse effect. Basically, greenhouse gas effect, as we will see later on, is about re-radiation or trapping of heat in the atmosphere around the earth, and this is what leads to warming of earth. The problem with these gases is when you release them, they tend to have a residence time which can vary from decades to hundreds of years in the atmosphere, which means they do not just go away, they stay in the atmosphere. So, burning of fossil fuels results in emission of variety of pollutants, not only carbon dioxide and nitrous oxide, but also other SOx, NOx gases, particles, soot, and we have seen nowadays a lot in TV and other media that how air quality with a lot of soot and particles, PM 2.5, PM 10 results in poor health, especially lung diseases in winter. There is some research that also suggests that airborne particles can increase the reflectivity of atmosphere, which results in slight cooling effect, but overall the emission of gases and particles together, they cause heating of the planet. Not only they cause heating of the planet, they also consume the exploitation, the production of these resources and conversion of these resources into energy results in consumption of significant amounts of fresh water, which is supposed to be for our use, but we waste this water in this process. So, on a very scientific basis, if you burn fossil fuels, we emit carbon dioxide, and this is driven by a simple reaction that carbon atoms react with oxygen and they give rise to CO2. So, 12 grams of carbon reacts with 32 grams of oxygen, resulting in 44 grams of CO2 production. Typically, 1 kilogram of coal yields about 10 to 30 megajoules of energy, which depends upon its type, what kind of coal it is. There could be multiple types of coal and not every coal is equivalent to other coal. So, some have high calorific value, some have lower calorific value. So, there is a variation in the amount of energy yield from coal. Let us say we take an average of 20 megajoule per kg, we get about 5 kilowatt hour energy per kilogram of coal. You can convert megajoule per kg into kilowatt hour. And 1 kilogram of coal contains about 700 grams of carbon. So, 6 to 700 grams of carbon, let us say. So, we can say 6 to 700 grams of carbon. So, 1 kg of coal consisting of 600 grams of carbon will yield about 2400 grams of carbon dioxide, if you go by the simple formula that is written there, which is nothing but 44 divided by 12 into 44 divided by 12. So, essentially you can see that 12 grams of coal combining with 32 grams of oxygen will give you 44 grams of CO2. So, from this you can determine how much CO2 that you will generate. So, 1 kg of coal will give you 2400 grams of CO2 because it contains 600 grams of carbon. Okay. So, you can say this is 0.6 multiplied by 44 divided by 12. Okay. So, 12 gram. So, now ideally speaking 5 kilowatt of energy should mean about 2.5 kilogram of CO2 or 1 kilowatt hour, which means 1 unit of electricity should result in about half a kg of CO2. But there are some other losses and factors. As a result, this number tends to be little higher. So, practically speaking, 1 unit of electricity will give you more than 0.5 kg of CO2. So, it could be anywhere from 0.5 to 1 kg depending upon the type of coal, type of power plant and so on and so forth. So, it will always be in the excess of 0.5 kg of CO2. So, let us take a pause, let us see what is the importance of the CO2. Okay. So, for this we need to understand what we call as carbon cycle. Okay. Carbon cycle is a very important thing in the context of global warming. So, we know that greenhouse gases, we have introduced the term greenhouse gases. Greenhouse gases are the gases which cause greenhouse effect, which means the warming or retention of heat in the atmosphere. So, carbon dioxide is one such gas. Carbon dioxide naturally is absorbed and released by variety of processes in the nature. For example, the dissolution of carbon dioxide occurs in processes such as photosynthesis or in the oceans. Oceans, if it is absorbed in oceans, it leads to ocean acidification, certain pH of water, and then again this is related to productivity as well as biomass production within the seas. And so, there is a natural process related to biomass and CO2 absorption and release in the atmosphere. Second thing that can happen is we have natural biomass. This natural biomass production, so of course, natural processes such as photosynthesis absorbs CO2, respiration releases CO2, respiration of especially from animals and other species. So, these are phenomena: respiration, photosynthesis, biomass production, soil related processes, erosion, weathering, which is because of weather related effects such as climatic changes or fires, etc. All of these processes, these are natural processes wherein the arrows show where does the carbon dioxide go. You can see the downward arrow shows the processes where carbon dioxide is absorbed, and the upward arrow are the processes where carbon dioxide is released. For example, things like production of biomass in the earth can release carbon dioxide, but processes like photosynthesis will absorb carbon dioxide. Fire of biomass can lead to release in carbon dioxide. These are all natural processes. On top of this, today what we have is resource extraction because of the requirement to meet our needs. So, we extract resources like coal, variety of other minerals from earth for which we need energy. We burn fossil fuels. For example, we extract coal, then we burn fossil fuel, and this fossil fuel is then converted into carbon dioxide. Natural processes such as volcanism, deforestation also can lead to release of carbon dioxide, because deforestation especially will lead to release of carbon dioxide, because the amount of carbon dioxide which could have been absorbed by trees is not being absorbed right now. Similarly, agriculture activities, rearing animals, producing food also results in emission of greenhouse gases. So, a lot of these human related activities, whether it is deforestation, burning of fossil fuels, agricultural activities, all of them emit carbon dioxide. Natural process, if we just had natural processes, we can absorb only about 4 gigatons of carbon dioxide into the, so we can release 4 gigatons and 4 gigatons can be absorbed, which means leaving a state of zero balance. But today what we are doing is we can absorb naturally only 4 gigatons, but we are emitting more than 55 gigatons of greenhouse gases including carbon dioxide. So, this is greenhouse gases of all types, not just CO2. As a result, you can see that our outflow is more than 10 times higher than the inflow or sequestration. This leads to pumping of or release of significant amount of greenhouse gases into the atmosphere at a much higher rate than we can sequester or store into the earth and oceans. And this is what is resulting in what we call as warming. So, this excess remains in the atmosphere, and this results in greenhouse gas effect, and this leads to what we call as warming or global warming. Okay. So, this is the importance of carbon dioxide or greenhouse gases which are produced when we burn fossil fuels. And these activities in this box, agricultural activities, resource extraction and burning of fossil fuels, these are primary drivers for this excess release. So, the greenhouse gas effect is basically when sun sends energy to the earth, and a lot of this radiation gets reflected, and is part of this is also absorbed as heat in the atmosphere. The energy which is emitted by gas is also trapped by gases which are present in the outer periphery of atmosphere, such as carbon dioxide or methane, and these methane or carbon dioxide molecules have such a structure, so that they are able to absorb infrared radiation, which is what is responsible for heat trapping. If this concentration of, so this is basically they basically absorb so if CO2 goes up, CH4 goes up, then IR absorption also increases, and as a result the warming in the atmosphere goes up, because IR is the one which is responsible for warming, and this leads to trapping of heat in the outer atmosphere. So, this is what is greenhouse gas effect, the trapping of heat or trapping of energy by gases such as carbon dioxide and carbon or methane, and because of their molecular structure and molecular frequencies, because they are able to interact with this radiation much better than other molecules. So, carbon emissions typically in the context of our country, for every unit of electricity we emit 0.7 to 0.8 kilogram of CO2 for a typical power plant in India, which is a significantly higher number. If you use 1 liter of petrol to drive a car, we emit about 2.35 kilogram of CO2. These numbers can vary a little bit from source to source, but this is an approximate number. Typically, carbon dioxide emissions are expressed in the form of CO2 equivalent, which means CH4 will have certain emission, N2O will have certain emission, and this can be represented in the form of CO2 equivalent. So, this is, as we will see later, it is expressed in the form of, it considers factors such as global warming potential of a gas and its residence time in the atmosphere, but all of these emissions from other gases can be equated or put in the context of CO2 emissions. On a general level, we can say CO2e or CO2 emission is equal to electricity that we consume multiplied by emission factor of that particular aspect. And in reality, these numbers will vary, they will depend upon the type of coal we use and type of process parameter, but these numbers are just to give you a context of how much carbon dioxide we produce approximately when we use electricity or when we use petrol. So, if you look at emissions on different scales, generally we measure emissions in gram or kilogram or metric tons or megatons or million tons or gigatons or billion tons. Million is 10 to the power 6, giga is 10 to the power 9, billion is 10 to the power 9. So, for example, if you look at these numbers, a new car, we all buy cars, and a new car can range depending upon its type from 6 to 40 tons. Just to make a new car, the embodied carbon dioxide, the amount of carbon dioxide that we have caused because of manufacturing of this car could be anywhere from 6 to 40 tons. If you look at country wise, America emits about 6 billion tons of carbon dioxide, China emits about 11 billion tons, India emits about 2.6 billion tons, UK for example emits about 0.34 billion tons. So, country to country differences are there, but these differences change when we look at per capita. Per capita matlab meaning per person. So, net emission divided by population, and then you get a significantly different picture. India has very large population, as a result per capita emission is much lower as compared to something like UK or US. So, global activities, anthropogenic means humans related activities, which is mainly because of industry and energy processes. So, carbon dioxide emission is about 38.6 gigatons per year. This is not greenhouse gas, but it is CO2 emission. Okay. And this has resulted in accumulation of CO2 in the atmosphere. So, pre-industrial level used to be 300 and today we have 460 ppm. So, these are some numbers per person annual emission. In case of US it is 20 tons, in case of UK it is 5 tons, in case of China it is 7 to 8 tons, in India is 1.9 ton. And if we want to prevent global warming from happening, what is desirable is that global average footprint must be lower than 2 tons, and today we have global average of 4 tons. So, we have a long way to go, and this is a very difficult task because we are all rapidly becoming richer and consuming more and more, as a result consuming more and more of energy. So, these are some numbers in this context. So, if you eat an apple, you can spend energy from 10 to 150 grams. Banana will give you 80 grams. Apple, there is a variation because it depends whether you live close to an apple or you live far from the apple. If you have a child or if you have a child in your family, then for every diaper that you emit 150 grams of CO2. So, you can imagine the number of diapers used will result in what amount of CO2. Even writing a SMS consumes energy, or writing an email consumes energy. So, it's a glass of water, it's about 60 milligrams of coffee, it's about 60 milligrams of CO2. If you iron a shirt, you are emitting 25 to 50 grams of CO2. If you drive per 1 kilometer of car, you are using 230 to you are emitting 200-300 grams of CO2. If you have 2 jeans, you can emit about 1 to 5 kilograms of CO2. If you have a mobile, it can lead to carbon emission factor of 10 to 100 kilograms of CO2. And if you have a computer and if you use your CO2 emission will be more than 100 kilograms over its lifetime. So, basically all these things that we have, they have a carbon cost, because in the manufacturing of these and use of these, we have emitted a lot of carbon dioxide, which is going in the atmosphere and accumulating. So, these are again some numbers. You can have a look at these numbers, whether you are flying or whether you are constructing a house or whether you are having an office, all of these have energy and carbon cost to them, and they are huge numbers. So, these gases, as we call them, they are greenhouse gases. They cause greenhouse effect, and there are multiple types of gases. CO2 is just one gas. We can have methane, we can have nitrous oxide, we can have gases like chlorofluorocarbons or perfluorocarbons, which are used as refrigerants or used in fabrication. These gases have different global warming potential. So, carbon dioxide, if it has a global warming potential of 1, methane has a global warming potential of 21, it is 21 times higher. If you look at nitrous oxide, CFCs, PFCs, they have even higher global warming potential, and they have different residence time. CH4 residence time is lower as compared to carbon dioxide, but it is still 12 years. For this, carbon dioxide is 200 years. But by and large, these two gases are the most dominant gases. 75% of our emission is CO2, and about 20% emission is that of CH4, remaining is of other gases. So, these two gases, carbon dioxide and methane, are two important gases which get accumulated in the atmosphere, and determine how much warming they will cause is determined by global warming potential and concentration in the atmosphere. But these are the two factors which are driven by fossil fuel burning for energy production and agriculture and refining and to run our industries. They are the primary drivers of global warming. So, these are some numbers for global GHG emissions. In 2022, we emitted about 58 billion tons of CO2 GHGs, 75% of CO2, 20% of CH4, and rest is nitrous oxide. So, you can see that America and China are the two largest emitters. India is again a very large emitter, third one, but on the per capita basis we are not among top in the world. On the per capita basis, countries like Canada, Australia, Saudi Arabia, Mongolia and some other countries, they emit far more carbon dioxide or GHGs than us. And most of the GHG consumption across the world is because of energy. 73%, nearly 3/4 of GHG emission is because of industrial use, because of energy use in industry, in transport, to drive vehicles and to heat or cool the buildings. About 20% is due to agriculture and forestry, and about 8 to 9% is because of waste and industry, natural processes that emit GHGs. but you can see that bulk of this is because of our use for energy and food. Okay. And as far as India is concerned, India consumes about 73% of its emission is because of energy for transport, building and industry. Agriculture and forestry is about 19%. So, 19 plus 73, you can see 92% is because of food and energy, and remaining 8% is because of waste and industrial processes which naturally emit energy. So, energy consumption and CO2 emission or GHG emission is intricately related to each other. It has resulted in large energy consumption since industrial revolution, has resulted in large CO2 concentration. It was mainly driven by United States earlier, but now India and China are also becoming large contributors to CO2 or GHG emissions, which have resulted in accumulation together. This historical emission starting from industrial revolution until today, it has resulted in accumulation of CO2 in the atmosphere from about 250 to 300 ppm to more than 400 ppm in the atmosphere, and this has significant consequences in terms of health of the planet, health of the planet's ecosystems, health of species including us who live on this planet. So, in the next lecture we will look at some of these consequences and the need for renewable energy. We will close this lecture here. Thank you very much.